That's wonderful. We are approaching the end of the session, and I want to say congratulations to you all. Remember where you were when we first started, and look at how much more you know now. It's been a wonderful, going on 10 weeks now, and hopefully you feel a little bit more confident in your skills and knowledge of operating systems. You are learning a lot of complex and sophisticated strategies and algorithms and management that operating systems do. And as you progress in your IT professional field, you will be encountering, new and developing technologies. And this is a good foundation so that when you do see new products on the market, you'll have some understanding as to what they are basically fundamentally created to do. All operating systems have to do management of processes, resources, devices, users, and so on. So as a result, they all have fundamentally the same management tasks. They just vary in the strategies that they use. And now with the newer operating systems that are coming out, they are concentrating on some of the management tasks more than others because of the more specified devices that it is being written for. For example, the Chrome that is being used at Google and the Chrome OS specifically for internet and using social networking and browsing the internet. So some of the other management tasks are put on the wayside for these newer operating systems. They are concentrating more on the mobile device that they are written for and the more frequent tasks that a user would use their mobile device for. So we have some exciting times moving forward in the technology area where we're going to get more and more used to using mobile devices, and our mobile devices will have more and more capacity for the more frequent tasks that people use mobile devices for. The only thing is there's a lot of controversy as to using a mobile device for your typical tasks that you use a computer for. Sometimes it's hard to type and create a document in a mobile device, so there's still a lot of areas for improvement. Storage may be an issue, but we do have the cloud out there that can help with your storage needs, so you don't have a large storage capacity in your mobile device. But as technology changes, more and more things are going to be integrated and used in these mobile devices, hence the operating systems will as well have to be new because it's new technology that is being used. But in general, we are now at week 10, and hopefully you were able to conquer week 9 material and math storage, understand the chapter, answer the optional questions. We will go over those optional questions from week 9 on Monday's office hours. Excuse me, week 10. We went over week 9 on Monday, and we will go over week 10's optional exercises on the upcoming Monday. So hopefully you are creating a reference and study guide for yourself for each week as you go through the week that will help you then when you study for the final exam. What's nice is you already took a midterm exam, so you already know what to expect, and a study guide will be given to you, but right now you can use those list of topics plus the optional exercises to help you study, and also the exercises at the end of the chapters to as well study and test yourself on the knowledge and skills that are put for you to learn in each chapter. Excuse me. Okay, so onward to week 10. Chapter 13, Input-Output Systems. Now we know we use our computer for input and output. We read information, we write information, we must store information on an external device if we want it to be permanent, because we know that memory is volatile or temporary. So anything in memory, when we turn off the computer, is gone. So hopefully you've learned the strategy when you use a word processor or any kind of application program, that you enable either the auto-saving feature that it offers, or you save your work, because in case your computer crashes, whatever is in memory will be lost. So we do have the use of external devices. Now we can get input and output from various devices. For example, input, you would use your keyboard, microphone, as I'm doing right now for this audio, for this presentation. So there are a lot of means for input devices. There are a lot of means for output devices, such as your hard disk, or your printer, or even your monitor. So the operating system has to make sure to coordinate these tasks. So when you type something on the keyboard, it then gets placed in that memory for keyboards, and then, it gets placed in the memory for the display, so you can see what you are typing, unless you are issuing commands. Then it will take your key press as an instruction and then pass it along to the CPU. So typically, though, anything that needs to be processed needs to be in memory and then passed to the CPU. Hopefully you already have this understanding. Usually the most time that any computer takes when it needs to execute an application is this reading and writing from the devices. The CPU is very quick, we already know this, but it's the passing of the information and getting the information for the CPU that takes the time. So we're going to learn some strategies on how to work with input-output systems. We already know the operating system is software, so it's a way of coordinating the hardware with the software. The hardware we know comes with device drivers that is used, or the program instructions that are used, so it can be operating that hardware device. But if we're going to send information from or take information in from a device, then we have some strategies. We can program it, we can use an interrupt, or we can use direct memory access. So various strategies that are used. Here are the topics. Again, do look at these topics. Make sure that you understand these topics. Have a brief summary or description of these topics and the key points for these topics. That'll be a nice reference sheet for you to use when you are studying for the final exam. Start creating your list and references now, while you're going through it, while you're exploring it, because then you revisit again and you just know that much more. Repetition is a key to learning new information. Here are your assignments. Hopefully you're able to complete them. You do have an exercise and also article response. While the article response does not give you any points, it is something for you to look at. As I mentioned in the office hours, you need to keep current with the latest and greatest technologies. You're not going to be in school forever, or you're not going to go back to school in order to learn something new that comes on the market. So you have to have a routine and a strategy to devote time to reading about this new information or viewing videos about this new information, and the internet is the best way to do this. So this article is put into the class for you then to get a glimpse and also access to some of this new information. But it is a rule of thumb, if you want to be a successful IT professional, you need to make a habit and routine to do this on your own, because this is how you're going to keep current, and this is how you're going to set yourself apart in the workplace, because you are aware of the latest and greatest. You are keeping up with the newest trends. A company needs people like that, because when they do any changes or updates or upgrades, They want to make sure that they are using the latest and greatest because it's expensive. So they can't be changing. Anytime anything changes, it's going to be every 2 or 3 months or 6 months, change everything. That's too expensive. But when you do any updates and prepare already for the new stuff coming, then that's an easier transition for a company and it saves money. So it's a good asset and it's good for you to know this information so that you can be successful. This is the exercise for you to complete. Again, assignments are due by Saturday. Okay, so input-output hardware. When you use your computer, you interact with a lot of this. We have storage, we have transmission, we have human interface. A lot of devices are plugged into your computer by a port. This is a connection point for a device. And this port is what an operating system program will use when it gets information or sends information. It sends it out through the port, and then it travels through the wire or cable into the device that's connected. Or you can have wireless transmission. Do any of you have a wireless keyboard or a wireless mouse or a wireless printer? Anybody? Yes, no, maybe so. Can you hear me? Hopefully you can hear me. Yes, you do. What do you have? Oh, you can hear me, but what about the question? Do you have anything wireless other than maybe, do you have a wireless or a Wi-Fi connection for the internet? That you probably have on your smartphone. But there's a lot of wireless technologies out there. Okay, if you have Wi-Fi connection, wireless all still needs some kind of device that captures that wireless transmission of data. So it still is a device somewhere. So you're planning to get a wireless printer. Yes, wireless printers are nice in that you can be anywhere and you can send information to your printer so it can be printed. Every wireless printer will have what is known as an IP address. And then if you have that address, you could be many miles away from your printer but still be able to send something to it if you wanted to do so. So there's a lot of complexity to operating systems to handle all of this, to make sure it doesn't confuse everything. It has to be very clear. It can't by accident send to your monitor something that you want to go to your printer. So it has to keep track of all this, and this is done by way of the ports. So here's a typical PC bus structure. As we know, the bus is how the information or data is transmitted throughout your computer. There's buses on your motherboard, and there's buses. This is like a route for the electricity to flow. And we have various buses here, and that typically is how, or the information is set out by the operating system to go then to its desired location or to get information from. In other words, these devices, they'll check. If information is coming through, it'll check, okay, where is this information supposed to go? You know, everybody will look at it and determine, is this for me? If it's not for me, it lets it to continue going down the bus. And there's also different speeds associated with the various buses. Obviously, the farther away it is and the more externally it is connected, the slower it will be. Anything inside and closer will be faster. So the input-output hardware, there's instructions that control the devices. Typically, they're called device drivers that have the instructions. Every device will come with it. If it's not plug and play, in other words, the operating system already has that device driver because it's a common device everybody purchases, then you would have a disk that comes with your device and you would then load it onto your computer. Devices have addresses. We all know and love addresses. We know how we did this with memory. But typically anything with a computer has to work with some kind of identification. This identification is typically known as an address. So your ports will have addresses. Your port number is like an address. So device input-output port locations on the PCs. Here's some examples. For most PCs, this is not comprehensive, it is partial, but this is how it is identified. If you have an address range between 000 to 00F, F is 15 in hexadecimal, that means it's a DMA controller, and so on. So everything is, there has to be some kind of logic and assignment to these items so that there's no confusion when these items are needed to be used either to read to or write from. Polling is a strategy that is done. This is like a handshake. For example, it would first see if it is available, and if it's available, then the transfer will go through. If it is not, it won't. So it waits to get some acknowledgement that it can then run through. So this one is like a polite way of interrupting. You don't actually just interrupt. You actually wait to be acknowledged. Once you're acknowledged, then you will start sending in the information. Interrupts, on the other hand, is where it does right away, that takes some action. So every interrupt has an associated list of instructions so that it knows then when it's interrupted what to do next. So the interrupt includes the actions that are going to occur. Any questions so far? So these are just strategies that are used. We looked at interrupts already when we looked at processes. Very similar. So here's an interrupt-driven input-output cycle. Again, we looked at a lot of this, or close to it when we talked about processes, because input-output was a process or a type of process, but it is so frequent and so much used that it kind of has its own separate cycles and scheduling. Now, direct memory access is a different type of strategy. This bypasses the CPU. In other words, the CPU is not used, but rather a DMA controller. So the controller kind of monitors what is going through and makes sure that it occurs. So it doesn't use a CPU. It's like you could think of a DMA controller as a mini CPU or a CPU helper. It takes over some of the tasks so the CPU does not need to be bothered. So that's a popular strategy, but again, you do have another piece of hardware that you have to work with. So this is the process that is performed when you do a DMA transfer. Do you understand this process? And see if you can see a DMA on your own computer. Is there a DMA controller? Something for you then to look at and see if you can find. If you have a Windows PC, typically everything is under Systems. So when you go into Control Panel, go into Systems and go into Device Manager. Your Device Manager will show all the devices on your computer and will also display if you have a DMA. Now, application input-output is where you program it. You have generic classes. This is where the programmer works with programmers to an extent, because remember, the operating system is a program, so it has to use program concepts when it works with this data that's being transmitted. So you have what is known as storage containers for the data, and also different ways of accessing the data. So it could be a character stream or a block. It could be sequential or random access. It could be synchronous or asynchronous or both. It could be shared or dedicated. Speed of operation, read-write, read-only, write-only. So there's a bunch of characteristics involved with data that's transmitted. Here's the kernel input-output structure. This kind of brings in, on the bottom, there's all the hardware, and on top, there's all the software. So this displays your bridge between your hardware and software. There is a video as well on the announcements page that kind of gives you a little glimpse into hardware, how hardware and software communicate. These are very important operating system programs. And I'm sure you ran into problems, perhaps with a hardware connection that didn't work. And there are a lot of issues that may be why it didn't work. It could be from the connection to the device itself, to the operating system, many reasons. Only because it's very complex as to how this communication occurs. Usually it's smooth, usually there's no problems, but sometimes there are. And because it is a hardware, you're working with electronic devices that are trying to be accessed through software and then passed to more electronic devices, there can be some miscommunication or just no communication at all. But there's a lot of programs in the operating system that do check for these possible errors. So your computer doesn't crash, but it'll just give you a message on the screen. For example, if your printer runs out of paper, there'll be a message on the screen. It won't just stop, and then you look at nothing, and nothing happens. Typically, it will give you a message. That's, again, for the more common errors or situations that can occur. If your plug is loose and there's no connection, it'll tell you no communication. But then there are the more serious types of problems that can occur and that may lock up your computer or crash your computer. But hopefully, there's a lot of other programs that are out there to help check and monitor to make sure when you turn on your computer, for one, it'll look to make sure whatever is connected and connected properly. It does what is known as a post test, and it checks for a lot of the common devices and to see what you do have plugged in. So then it can activate all the device drivers, then be ready to use your computer. Here's some characteristics of input devices. We did talk about, again, performance, speed. Usually the items that take the longest time is data transmission from hardware devices, especially external hardware devices. So here's some characteristics of these devices and the things that are looked at. So look at your devices on your computer. What are the speeds of your devices? Hopefully you already know the size, for example, of your hard disk. And what's the speed of your CD drive or DVD drive? Start looking at your devices. What about your keyboard? What are some characteristics associated with your keyboard? Obviously, it has keys. Is there anything else associated with your keyboard? Same goes for transferring to printers or information coming from a printer. How fast does your printer send information? So these are all those statistics that are involved when the operating system works with this input-output devices, and also as someone who uses it to know, what speed, what is the speed that is needed? Do they need it very fast, or is it okay if it's not so fast because it's not used that much? Obviously, anything faster costs more money. Again, different types of input-output methods. Something, again, for you then to look at and know between the kernel and the user and system calls. We did discuss this already, I believe, in Chapter 1 and Chapter 2, so some of this should be familiar with it. Again, it's just a little bit more specific when it comes to hardware. So you can review the information that you had then and look at it now. Kernel input-output subsystem scheduling. Buffering. Buffering is a way of storing it, kind of getting it closer to the device. But since the device is busy, it can't be sent right away. It has to wait. So buffers is a way to then get the information little by little closer to the device, and then when the device is ready, it can be given. So it is a good way then, because the way we use, again, the speed and the time that it takes to transfer this data to these devices can take a lot of time. So there's a lot of strategies to minimize this time by adding extra help. Buffers are an extra help to the transmission of the data. Device status table. Very indicative of the addresses. Again, every device has an address. When you have a request, you could see some are idle, some are busy. Who's requesting what? When there's a lot of requests, obviously some requests have to wait. Very similar to any process that's scheduled. Again, some of this should be familiar. Here's the Sun Enterprise 6000 device transfer rates. These are some of the devices on the Sun Enterprise 6000. Now, this is more known as something you'll find in the workplace. You will not have one of these at home. They are typically known as workstations, where they are in a workplace, set up as a workstation, typically using network servers. But it itself will have some capabilities. And these are some examples of some transfer rates. I know there's times that you sat in front of your computer, wanted to do something, and you just have to wait. You can speed up the performance of your computer. There are some routine maintenance that you should do. Disk cleanup is one, disk defragmentation is another. So there are some strategies to help keep it at optimal performance, depending on, obviously, what you need to do. Okay, kernel input-output subsystems. Again, caching, spooling, device reservation. Again, these are all strategies to help. We talked about buffers. Caching is, devoted storage for a particular purpose. We already looked at memory caching. Spooling, another strategy. Hold output for a device. Device reservation provides exclusive access to a device. Now, this is good for critical situations. For example, a warning or alert system. You may want to have exclusive access, and when there is some alert or warning that comes through, that it's sent through no matter what's going on. Error handling. Didn't mention that before. You should have a message. You should know. But then again, you have data transmission. There is a lot of strategies done here because when it's transmitted, it has to be checked to make sure it's transmitted correctly. It has to try to see to make sure the data that is sent is the same data that is received. And why this is so? Because it is just electrical signals. And a signal by accident can be changed. There could be noise on the line. Noise is, for example, when you're just talking on your smartphone and there's a big storm, you may not get a good reception of whoever you're talking to. So there is a lot of strategy being done as to how to make sure to check what's coming through is what should be coming through and hasn't been changed. Remember, we're just dealing with zeros and ones. Either there is electricity or actually it's a frequency, and then there isn't, or lower frequency. So it can very easily be wiped out and have no signal, and that way you're not going to have any transmission. Or one of the bits is incorrect. There can be a surge in the power. So there are a lot of issues that can occur, and the program has to be prepared for that so that it can alert the end user that something's wrong. And there's typical error numbers. Anytime you write a program, that is something you should carry through in any kind of program that you write. You need to have some error checking to make sure whatever is being done is done correctly. And then protection. So this is to protect you from interrupting a process that may be going on or sending something to a wrong area. As a programmer, the most common type here is sending something to a memory location that is not reserved for you, going out of your bounds. So when it deals with memory, memory mapping, port memory locations, it's got to be protected. And a lot of this falls into as well security. This has to be protected. You know yourself, on the internet, we have to be secure with our data transmissions. Make sure whoever is receiving it should be receiving it, and it's sent to the correct person or correct device and not rerouted somewhere else. This is an area where a lot of hackers get access to your information. So there has to be a lot of strategies to protect it. Obviously, it can happen. There's viruses that can cause problems. There's hacking and breaches of security all the time. So this is one area, again, if you like operating systems, this is one area that always needs programmers, because you always have to deal with new viruses or new hacking strategies so that security is proper and the data is kept safe and not leaked into the wrong hands or corrupted. So use of a system called to perform I/O. Again, we looked at this when we were looking at Chapter 3 and Chapter 2, processes. So this should be familiar, but this is how you can translate the actual, again, it's taking electric signals and devices and how to make sense out of these signals that are being sent to or from these devices and being able to put it into a program so that it could be worked with. So it can be transferred and made sense of. It has to make sense, at least to the end user. Kernel data structures, just like we have process blocks. These are all information about the device and the data. So there's a lot of information that is passed in, not just the data itself, but other information, like what device it's coming from or what device is it supposed to go to. How large is this data? You know, there's information about the data so that when it goes to the other end, it's checked to make sure it is transmitted properly. So in order to check anything to make sure it's been transmitted properly, you have to have some statistics on it. Size is the main one, to make sure all of it goes to your printer, not just half a page or just the page you see on the screen. When you want the entire document printed, it doesn't just send one page. And obviously it sends what you see on the screen to your printer. So a lot of, again, sophisticated checking, error handling. Unix input-output kernel structure, you can take a look at this. In week 13, actually, we're going to go on more in depth in Windows, but Unix is a very popular operating system. You should be familiar with it. More than likely, you will see it in the workplace. It is commonly used in addition to Windows and in addition to Mac. Most workplaces will have all operating systems pretty much represented, to at least these three. You may have some more specifics like IBM for their mini computers or for workstations. So InputOutput request to hardware operations. Again, information that you need to have. Any questions so far? Are we all clear on this? It's just a matter of just knowing it and learning it. Any questions? Yes, it's clear, or yes, you have a question? I believe you mean yes, it's clear. Okay. Okay, I'm going to take a capture of the list of participants so that I can use this to log in your attendance. Again, these are required, so make sure you show up. If you did not, then view the recording and offer a summary. But again, they check to make sure you're here, so you are to be here. And I'm glad that you are here. Okay, life cycle of an input-output request. Do you understand this? Again, it goes back to what you already kind of refreshing your memory on process requests. So do know the different aspects of this. Streams. What is a stream? Again, it's this how things are transmitted. Do you know those terms? We're talking about characters or blocks. We talk about synchronous, asynchronous. Do you know all this terminology? It is important not only for operating systems, for many. Streaming video, if you ever heard of streaming video. Full duplex. There's a single duplex. Single duplex is where there's only one-way data transmission, or one-way. Half a duplex and full duplex. Communication both ways. Half duplex communication one way, and only it can go both ways, but it only can go one way at a time. And then single is, for example, like a TV. You can hear your TV, but if you talk, whoever's on the other end of your television cannot hear you. Half duplex is similar to walkie-talkies. You can talk, or an intercom system, where if you have to press a button to talk and let it go to hear, that means it's half duplex. Full duplex is similar to your phone or smartphone. You both could be talking at the same time. You both can be listening at the same time. But again, when this occurs, it's sophisticated to make sure that your information is sent to your receiver and transmitted to your receiver, as well as the other way around. If you're talking on the phone to somebody, that other somebody should hear you or be able to hear what you're saying. Stream structure. Again, another diagram. Performance, something to look at. Go again, look at the devices you have on your computer. What are the performance statistics for your device? Look into your control panel system, and then device manager gives you all the information about your devices. Go look at that and go see. It'll identify all the devices. It'll identify the manufacturer, the brand, the device driver, a lot of statistics. So get to know what's on your computer. Again, what's on your computer, pretty much you're going to run into something similar in the workplace. So get a good understanding what's in front of you. Or if you're in the workplace, compare what you have for your personal use with what you're using in the workplace. Again, it just gives you more information and hands-on information. You've seen these devices. You've worked with these devices. You know these devices. That's a good way then to master the skills needed. Intercomputer communications, this is your network. Data transmission through networks. It could be wired or it could be wireless. but it has to be done and it's done correctly. How to improve performance. This is for internal operating systems functionality. It is not necessarily something you can do when you plug in a device into your computer. Some devices do come, though, with some options and optional settings. So another area for you to explore to see if you can change some settings. One example is your battery. You do have some optional settings for your battery to have a full performance, but then it drains quicker, or to have a medium performance so it doesn't get used up too quickly. However, that will slow down performance. So look at the various options of your devices. Can you make some settings for them that maybe will save battery life, or will save time, or speed up time? Again, everything comes with default settings, but see if there are any settings you can change. This will be useful information for the workplace. For yourself, you know what you need and you know what you do, so you would have these certain settings. But in the workplace, you may have a variety of requirements and needs depending on what it's being used for. Sometimes it has to be faster. Sometimes it has to be slower. Sometimes it has to be able to switch between the two. So start knowing the statistics. If you can't find, look on your computer and then look on the internet. Every manufacturer will have statistics and specifications about their hardware device. And then you will also know how it can be configured for your operating system so that you can see what changes are possible, what changes are not possible. But this is good information for you to know. Okay, so do we have any questions so far? Are we all good on the information on input-output? Again, do look at what you have on your computer. Take the time. Look at what you have in the workplace. Take the time. This is how you will know. Don't wait for someone to tell you or teach it to you. You got to learn how to learn on your own to be a successful, very successful IT professional. You can't wait for someone to tell you to do it and learn it. You got to learn it on your own. So find something that you have passion for, that you are interested in, so then you don't mind sitting at the computer or looking up the information and resources to learn more about it. Okay, with that I'm done. So I will leave you with this extra time to either collaborate with each other, start looking at more resources and review the material in the classroom, or complete the exercise if you haven't already. Also the article, I will leave you this extra time to review the article. I know there's no points, but still it's good information to know. And also do find a routine where you do this on a routine basis, because that's how you will keep current. And that's how you will be a successful IT professional. If you do not keep current, you won't last too long. You won't be considered an asset to the company. They want someone who's always on top of it and knows the latest and greatest. And the only way to do that is go and learn on your own. You can't wait. You got to do it. So find some good sites that you already know of that gives you the good information in what you're interested in. Okay, with that, have a great evening, and I will see you on Monday. Don't forget, assignments are due Saturday. And almost 3 more weeks. We have week 11, 12, and 13, and then week 14 is the final exam. So we are nearing the last stretch here. So make sure you have all your references and start working on your studying for your final exam. It'll make you that much better when you take it. Okay, have a great evening, and again, I will record your attendance in the classroom. And see you next Monday. Have a wonderful weekend.